So now I welcome you all in the second part of our lecture on measures of central tendency. So in first part we have seen about the arithmetic mean, different methods of estimation of arithmetic mean. Now in this lecture we will see how to measure the geometric mean, harmonic mean and weighted mean. And in this class we will be finishing the actual measures of central tendency. So first of all, why this geometric mean is needed? What is its advantage over arithmetic mean? So when we have data on increase in ratio or percentage, so when we are having data on increase in the ratio or percentage, suppose we have a poultry unit which earn profit of 10% in the first year, 30% in the second year and 20% in the third year. So if we want to know what is the average profit in these 3 years, so we don't have actual value but we are having values in terms of percentage. So it is not the arithmetic mean, because with what these numbers mean is that on the first year our investment was multiplied. It was multiplied, not added to, and it was multiplied by 1.1 factor of 1.1. On the second year it was multiplied by 1.3, and during the third year it was multiplied by 1.2. So it was not added but it was multiplied. So in this case we will apply geometric mean. We'll see how it will be applied. So now the definition of geometric mean. So actually geometric mean can be defined as the nth root of product of values. So this is a very important definition. The nth root of product of value. That means suppose you are having one data set and it comprises of values 1, 8 and 64. So here the geometric mean will be under root nth root of product of values. So the product of values are 1 into 8 into 64. So this product of value will be giving us geometric mean. So when we will solve this, we'll get the geometric mean of 8. So by definition geometric mean is the nth root of product of values. Now what are the various methods of computation of geometric mean? So there are mainly two methods. The first one is root method that we have already seen. So it is nth root of product of values. So when the values of items are small, simple and capable of being factorized easily. So this method, root method, is applied when the values are simple and easy to be factorized. Factorized means we can easily find out the nth root of that particular value. So if the values are big or complicated, then the geometric mean is more easily calculated by logarithmic operation method. So there are two methods. First one is root method and second one is logarithmic operation method. So when your data is simple, easy to be factorized, then we will use the root method. But if your data is having certain values which cannot be factorized easily, or you are having big amount of data, then we will go for logarithmic operation method. So the second one is the logarithmic operation method. So in logarithmic method there are two methods, direct method and shortcut method. So in direct method what we are doing, the direct method that too for all the kinds of data, that means individual data or raw data, then in group data, discrete series and continuous series. So there are slight variation in the formula, and this variation we have already studied when we were studying the arithmetic mean, the formula for arithmetic mean. So I am confident that you will be able to appreciate the differences in the formula for different kind of data series. So we will see for individual series only. So geometric mean is equal to antilog of what? So antilog of summation log x divided by n, that is total number of observation. Similarly, in shortcut method, as we have already seen in our arithmetic mean class, that we have to take an assumed mean. So here the formula will be changing accordingly. Geometric mean is equal to antilog of log a. What is a? A is the assumed mean plus summation d log a, that means the difference between the log a and log x, and that will be divided with the total number of observation. So I think this is clear to you. I have already written log a is the log of assumed mean, and log summation d log a means sum of deviation of log x and log a, that means log x minus log a. So this is about the second method, that is logarithmic computation method. Now we'll see one example. With one example, I think already we have seen the example of root method, the example of 1, 8 and 64. Now we will see the example of logarithmic method. So first of all, we'll see this data. Calculate the geometric mean of 5, 10, 15, 20 and 25 by logarithmic operation method by both direct and shortcut method. So you see, we are having data 5, 10, 15, 20, 25. So what we did, we find out the log of these values. So these are the log of this value. I have already written here. And for second method, that is by shortcut method. So by shortcut method, I have find out the difference d log a. That means the difference between the log of x minus log of assumed value. So here the assumed value a, I have taken it as 10. So what will be the log of 10? The log of 10 will be 1. So 1 minus 0.69 is equal to minus, or sorry 1 0.6 minus 1, 0.6 minus 1. So just a minute. So what we will do, 0.6 minus 1, 0.69897 minus 1 is equal to minus 0.30103. So similarly, I have find the d log a for all the values, that means so, and at last I have find out the summation log x and summation of d log a. So after preparation of this table, now we will put the formula in, put the values in the formula. So here you can see this is the formula for direct method. So geometric mean is equal to antilog. You have to find the antilog. Antilog of what? The antilog of summation log xi divided by total number of observations. So here we have already taken the summation of log xi. If you want, we can see it in the previous slide. This summation is 5.57403. So here in direct method we have kept the 5.57403 divided by 5. So antilog of 1.1 is equal to 13.02, sorry, 13.0258. This will be the geometric mean of that by direct method. By shortcut method also, we have to find the antilog of log a plus d summation d log a. So summation d log a we have already calculated 0.57403, and summation of log a. So log a is assumed mean, a is 10. So log 10 is equal to 1. And finally here also we are getting the geometric mean as 13.0258. Now what are the properties of geometric mean? So for any series, geometric mean is smaller than arithmetic mean. So you have to always remember that for any series, geometric mean is smaller. However, when values are equal in a series, geometric mean will be equal to the arithmetic mean. So geometric mean is always lesser than arithmetic mean, but when values of a series are equal, then geometric mean will be equal to the arithmetic mean. Now the second property is if any value of a series is 0. So suppose you are about to calculate the geometric mean of 1, 0 and 64. So you will get the geometric mean as infinity. When any value of a series is 0, then geometric will be infinity, because when you are doing finding out the under root of 0, it will always give infinity. It will always give infinity. So that is why if the value of a series is 0, the value of geometric mean will be infinity. That means it cannot be defined. Then third one, the geometric mean cannot be calculated if total number of negative values is odd. So when your data series is having negative value, then finding out geometric mean is difficult. But when in a data series, suppose you are having two negative value, so what will happen? Then you have to get the product of values. So product of two negative value will come positive. Product of two negative value will come positive. In that case, you will not find any difficulty in finding geometric mean. But suppose you are having either one negative value or three negative value or five negative value or seven negative value or any odd negative value, in that case finding out geometric mean will be difficult. You cannot find out the geometric mean because the under root of negative value cannot be determined. So when the negative values are odd, you cannot determine the geometric mean. So these are the two important properties of geometric mean. Another one, the geometric mean raised to nth power equal to product of value. So suppose you are having geometric mean of 16. Suppose you are having geometric mean of 16. So if you are raising the 16th raised to n, so what will happen? It will be equal to x1, x2, x1 into x2 into up till xn. That means when geometric mean raised to nth power equal to product of values, the geometric mean raised to nth power of equal to product of values. So this is the properties of geometric mean. Then geometric mean of different series with same n and same product. Suppose you are having geometric mean, you are having two different series, and these two series is having same number of observation and same product also. That means if you are multiplying these two series, you are getting same value. Then geometric mean will be always equal. That means suppose you are having value consider this series. We are having series of first series is 1 and 36. So n is 2 and product is 36. Then second series 2 is 2 and 18. So n is again 2 and product is again 36. Then third series is 4 and 9. So n total number of observation is 2 and product is 36 again. So in this case, always geometric mean of all this series will be 6. So suppose you are having two different series and having equal number of observation and also you are having equal product value, then geometric mean will be always equal. Then another property is the product of a series of number remains the same even when each of the series is replaced by its geometric mean. Suppose you are having geometric mean, suppose this value, you are having value 2 and 18. So 2 and 18 geometric mean is 6. So suppose instead of the product of series of number remains the same even when each number of series is replaced by its geometric mean. Suppose 2 and 18, if you replace 2 and 18 by 6, that means by its geometric mean will remain same. So that means कि if value of a series, value of all the all the value of a series is replaced by its geometric mean will remain same. So these are the major properties of geometric mean. I hope it is clear to you. If not clear, if you are having any doubt, you can ask me in the comment box. Then, what are the utility of geometric mean? So first, for averaging the ratio and percentage. Already we have seen that if you are having data in the form of ratio or percentage, you can find it. To find the average of index numbers. So in that means ki very small numbers. Index numbers, if you are having, you can find the if you are having data in the form of index number, you can find the average by geometric mean. Then when it becomes necessary to give more weight to small items. So if you are having necessary to give more weight to small changes and avoiding the big changes. So to give emphasis of small changes, you have to find out the geometric mean. In the gradual increase or decrease, that means the small changes of a given value or a number over certain period of time, example in finding compound interest or depreciation. In case of finding out the compound interest, you can use the geometric mean. Now, what are the merits of geometric mean? So, these all utility, merits, etc. you may be asked in your examination, either in short notes or in any way in the objective question, you or in definition you can get this type of questions. So, merits of geometric mean, it is rigidly defined. Why? Because it is having well defined formula. Then it is based on all the observation. So we have already seen the formula. You see all the observations are used in the formula of geometric mean. It gives better result when we have to calculate percentage increase in any variable. So we have already discussed that percentage. In case of percentage changes, geometric mean is well applicable. Now, what are the demerits? So demerits, it is cumbersome to compute because it is having formula. It cannot be calculated by layman. If any observation is 0, so this is also very major problem. If any observation is 0, the geometric mean will be 0. Then again, if the observations are having odd negative value, then also it cannot be calculated. This already we have seen. Now, another measure of central tendency is the harmonic mean. Okay. We have already seen that measures of central tendency is divided into two parts, actual measures and positional measures. So here in actual measures we have already seen arithmetic mean. Now second one was geometric mean, and this third one is the harmonic mean. So what is harmonic mean? It is defined as the reciprocal of the arithmetic mean. Reciprocal of the arithmetic mean of the reciprocal of the values of a variable. So here you just see this definition is a bit complicated, but if you divide into two parts, it is easy. So here in harmonic mean you have to take 2 times reciprocal. The first one is the reciprocal of the values, and second time is the reciprocal of arithmetic mean. So what you have to do, you have to find out the reciprocal of all the values of a series and find the mean of that reciprocal. And after finding mean, you have to reciprocate it. That means you have to take the reciprocal of that mean. So by example, we will see it in easy way. Okay. Now this is the formula. With the direct method, you just see, first of all, we have find out the reciprocal of all the observation. Then we have find out the mean of all the reciprocal, and it is again made reciprocal. So after simplifying, you are getting this formula. Harmonic mean is equal to n, that is total number of observations, divided by summation of 1 divided by xi, that means all the observation. So similarly, for classified data or group data in discrete series, n divided by summation fi by xi, and for continuous series, n divided by summation fi by mi, that is mid value of the class. Now we'll see one example for ungrouped data. So if we want to find out the harmonic mean of this data 5, 10, 15, 20 and 25. So what we will do, first we will find the reciprocal of these observations. So reciprocal of 5, 1 by 5, it will be 0.2. 1 by 10, it will be 0.1. 1 by 15, 0.667. 1 by 20, 0.05. And 1 by 25, 0.04. So now we will find the sum of all these reciprocal value. So it will come around 0.4567. And finally, for getting harmonic mean, we have to make it reciprocal, and that too by the total number of observations. So finally harmonic mean is equal to 5 by 0.4567, and you will get the harmonic mean as 10.948. So as the definition of harmonic mean appears complicated, but this calculation is very easy. You have to take 2 times reciprocal by considering the total number of observations also. Now the second one is the group data, that is discrete series. So let the frequency of values. So in group data, you know, there will be the frequency of the values. So the values are 5, 10, 15 and 20, 25, and the frequencies are 4, 3, 5, 4 and 4 respectively. So what we will do, we will write the formula, that is n divided by summation f by x. So n is 20 because 4 plus 3 plus 5 plus 4 plus 4, it will be 20. So 20 divided by summation f by x. Summation f by x. So if you will put the summation value of all the frequency divided by all the observation f by x, then you will get the harmonic mean as 11.15. So the calculative procedure is easy if you are remembering the formula. So remembering a formula is very essential for calculating it. And if you will remember formula easily, if you understand the definition well. Now what are the properties of harmonic mean? So for two observations, say x and y, if you are having two observations x and y, the harmonic mean is equal to the ratio of product of values and their arithmetic mean. So if you are having two value x and y, so what will be the harmonic mean? Harmonic will be the ratio of product of value. Product of value is xy divided by, that is ratio of product of values and their arithmetic mean. So what will be the arithmetic mean of x and y? The x plus y, because these are the two value, x plus y divided by 2. So this is the arithmetic mean. This is the harmonic mean of two values x and y. And finally, in simple form, 2xy divided by x plus y. So this is the property of harmonic mean. Now, what are the uses of harmonic mean? So similar to what we have seen in geometric mean, the harmonic mean is also having some specific use. When the frequency distribution is skewed to the right. So this is skewed to the right, it is bit early to understand, by you, because we have not studied the distribution of data. So this is the shape of normal distribution of data. Any data is, particularly if you are taking natural data, it will be normally distributed. But when data is skewed rightward, skewed to the right, if it is skewed to the right, that is more number of observations, you will study in later classes. If it is skewed to the right, then we have to use the harmonic mean. Also, in case of graphic representation of data, when the data is represented in the graphical form, you can use the harmonic mean. In computation of average rate of speed, when you are having average rate, average changes, average speed, then in that case you can use the harmonic mean. So when you are having averages, when you are having a ratio and percentage, you can use geometric mean. But when you are having averages, you will have to use the harmonic mean. Now what are the merits? So it is rigidly defined because it is having also well defined formula. It is based on all the observations because we are considering all the observations in the formula. It is capable of further algebraic treatment. So this all means are capable of further algebraic treatments. That means you can multiply it, you can divide it, or you can go for any other algebraic treatment. it can be calculated even when series has any negative value. So this is the advantage over geometric mean. So even if you are having a negative value, you can calculate it. The next one, it converts the skewed distribution into the normal. So we have already studied that when data is rightly skewed to the right, we will use harmonic mean, and by applying harmonic mean, the data will return back to the normal distribution. The next one, it gives straighter curve than that of the arithmetic or geometric mean. So when we will draw it graphically, the curve for harmonic mean will be straighter. That means it will convert data into the form of normal distribution. That is why the curve will be straighter. Now what are the demerits? So it is not easy to understand by an ordinary man or by layman, because you have to take 2 times reciprocal. So sometimes the formula will be cumbersome, its calculation is cumbersome. The same thing, it cannot be calculated if any of item is 0. Again here the problem is that if any of the value is 0, that means ki the reciprocal of 0 1 that means 0 1 by 0, so it will be infinity. So you cannot calculate the harmonic mean if the value is 0, same as that of the geometric mean. Now relation between arithmetic mean, geometric mean and harmonic mean. So for any series, arithmetic mean is always greater than geometric mean, then harmonic means. That means ki arithmetic mean is coming in the number 1, then geometric mean, and then harmonic mean. So but if all the observation are same, then these 3 means are equal. So in normal condition, arithmetic mean will be always greater than geometric mean and harmonic mean. But if all the values of a series are common, then arithmetic mean, geometric mean and harmonic mean will be equal. So this is the important relation between arithmetic mean, geometric mean and harmonic mean. Then another relationship for 2 observation. If you are having only 2 observation x and y, then arithmetic mean, product of arithmetic mean and harmonic mean will be equal to the square of geometric mean. So if you are having only 2 observation, then product of arithmetic mean and harmonic mean will be equal to the square of geometric mean. So just we will understand by this example. If we are having value 1 and 4, this 2 value. So what it wanted to tell, the arithmetic mean, if you find the arithmetic mean, 4 plus 1 divided by 2, it will be 2.5. If you want to find the geometric mean, then 1 into 4 under root 2 under root 1 into 4. So it will be 2, geometric mean will be 2, and harmonic mean it will be 1.6. So you can see the arithmetic mean is greater than geometric mean and harmonic mean. So the first relationship is clear. The second one, if you multiply arithmetic mean and geometric mean, that means 2.5 into 1.6, it will give the square of geometric mean. So the geometric mean is 2, and here you are getting 4. So if you are multiplying arithmetic mean and harmonic mean, the values will be equal to the square of geometric mean. Now the another mean, the last of these means or actual measure of means, the weighted mean. So in the calculation of arithmetic mean, every item is given equal importance or is equally weighted when you are calculating the arithmetic mean. So if you remember the formula was x1 plus x2 plus x3 plus xn divided by total number of observations. That means all the values x1, x2 and x3 or xn are given equal weightage. But many a times in natural condition you will get some condition where the different values will have different weight. In that case you cannot apply simply the weighted mean. So arithmetic mean. So there you will have to apply the weighted mean. So many times it so happen that all the items are not of equal importance. Example, You take simple example. In V.Sc AH system of examination, the different courses are given different weight or credits. You see, you are studying AGB. The credit of AGB is 3 plus 1. But if you are going for some other courses, there the credit or weight of the course is different. So based on that, how you are getting your OGPA? Based on the credit of that particular course. So according to their importance and their weighted mean is obtained. So for getting weighted mean of your credit or of your courses, we are applying the weighted mean. So suppose if x1, x2 up to xn denote the n values of variable x and w1, w2, wn are their associated weights, then the weighted mean is given y. So what will be the weighted mean? Weighted mean will be the simple of that of the arithmetic mean, but instead of applying no weight, here in this case you are applying weight. So you see this is x1 plus x2 plus x3 plus xn divided by n, but instead of that you are applying the weight, associated weight also. So weights are w1, w2, w3 up to wn, and it is divided by all the weights, that is w1, w2, w3 up to wk. So simply the formula will be summation wi xi divided by summation wi. So this is the formula of weighted mean. Now take the example. The marks of a student in practical and theory in 2 subjects are given below. So this is the practical course of 1 credit. So 70 and 50%. The marks and percentage. The marks is 70 and it is 50%. Then theory, the 80 and 70%. So this is the marks of a student in practical and theory in 2 subjects are given below, 70 and 80 and 70%. So what we did, the practical is having 1 credit and theory is having 2 credits. So what we did, we find out the weighted mean. So 1 into 70, because 70 is having marks in practical and credit is 1. Then in percentage, for percentage also 50 into 1. Then for theory it is having credit 2. So it is marks of 2 subjects. So 70 and 50. Now for theory portion, the marks is 80 and 70 and the credit is 2. So 2 into 80 plus 2 into 70 and overall average in the lower side. So finally we get the marks as 72. So this is the weighted mean of the marks that we have obtained in these 2 subjects having different credit hours for theory and practical. So what are the use of weighted mean? Weighted mean is used when the number of individuals in different classes of a group is varying widely. When the number of individuals in different classes, suppose you have formed a class, discrete series or continuous series, and the number of individuals in different classes are varying, then you have to go for weighted mean. You will find a lot of utility of this weighted mean in the latter part of your course or in other places also. When the importance of all the items in a series is not same. So many times, suppose you want to know the value of product of cow. So if you are getting 2 kg of milk and 2 kg of dung, so these 2 value of milk and value of dung is not same. So in that case, to find out the overall value of a cow, you have to apply the weighted mean. And in many places, many similar situations, you have to apply the weighted mean. When the ratio, percentage or rates, example quintal per acre, rupees per acre or rupees per liter, etc. to be averaged. So when the ratio, percentage and rates are to be averaged, you have to find out the weighted mean. So these are the utility of weighted mean. Another utility, when the average of a series is to be obtained from the average of its component, you have to find out the average of a series, and you are having average of different components, then you have to find out the weighted mean. Then it is particularly used in calculation of birth rate, death rate, index number, average yield of the crops, etc. So it is having many utility. You will appreciate when you will go further in your studies in this course. So with this I am completing the actual measures of central tendency. In this we have seen the arithmetic mean, geometric mean, harmonic mean and weighted mean. And in the next lecture we will see the positional measure of central tendency, that means median and mode. And in the last the third series of the lecture, after completing these two portions, median and mode, we will be completing the measures of central tendency. Thank you.